Hi guys, welcome back to IB Buddies. Today we're going to do gas laws and talk a little bit about what ideal gases are. To start off with, we have pressure. So this is just the force per unit area. You can think of this or imagine this when, for example, you poke a needle with a really low area. You feel a lot more pain than if you were to apply the same amount of force on the table. And that's just a physical way of representing pressure. Then the assumptions we use in ideal gases that allow us to calculate stuff and approximate them for real gases is we say that they have a large number of particles, which allow us to take averages and calculate things. The volume of the particles is negligible compared to that of the container. There are no intermolecular forces, and the particles move randomly in all directions. Also, all collisions are elastic, which means that kinetic energy as well as momentum are conserved, and the duration of these collisions is negligible. Also, the potential energy between the particles is zero. Now, the best times that these assumptions can be made about a gas is when it's at a high temperature, at a low pressure, or it has low density. So, how to work out moles. Apologies in advance because there are 3 n's in this calculation, so don't get confused. Little n here is the number of moles. Big N is the number of particles in a substance. And Na here is Avogadro's constant, which is 6.02 times 10 to the 23, which is the number of particles in 1 mole of a substance. And you'd work out either the number of moles or the number of particles in a substance by substituting in a number from the question you're given and then using Avogadro's constant. So there are 3 ideal gas laws you should know about. There's Boyle's, with an S, law, which states that pressure is proportional to 1 over V. There's Charles, which is volume is directly proportional to T. And there's Gay-Lussac's law, which is pressure is proportional to temperature. Now, if we combine all those 3 together, we get PV over T is a constant, which is sometimes also written as P1 V1 over T1 is equal to P2 V2 over T2. It's the same thing. And then in IB, we get given the formula PV equals nRT, R being the gas constant, which is 8.31, or the equation PV equals NKBT, where KB is Boltzmann constant, which is 1.38 times 10 to the minus 23. This is just a fancy way of writing PV over T as a constant. We just know that the constant is now the moles times the gas constant, or the number of particles times the Boltzmann constant. And as always, you just plug all the numbers you get from the question into these and get an answer. Now, internal energy and pressure. These are just part of the energy in the gas. So it's internal energy is related to temperature and kinetic energy. And here is the formula, 3 over 2 NKBT, which is also equal to the kinetic energy of particles in the gas. Then we've got pressure is 1 over 3 rho v squared, which rho is the density of the gas and v is the speed of the gas squared. The 1/3 comes from having 3 possible directions or axes that the particles could go through and hit containers for. And other than that, you just need to know how to use these equations. So yeah, that was the end of the video. Another quick summary of a physics topic. I hope you enjoyed it and learnt a bit, and have a great day.